Hello, my name is Professor Fox, and this is my video on radioactivity. What is radioactivity? A dictionary named Merriam-Webster puts the definition as the property possessed by some elements, such as uranium, or isotopes, such as carbon-14, of spontaneously emitting energetic particles, such as electrons or alpha particles, by the disintegration of their atomic nuclei. Now, that may just seem like a bunch of nonsense to you, but that simplified, that means you have an atom that's sick, but sneezes out a particle and suddenly becomes better again. That's basically radioactivity and simplified. How can radioactivity be dangerous? You probably have heard that radioactivity can be dangerous. It can cause two types of sicknesses: radiation sicknesses and cancer. Radiation sickness, the side effects include bleeding, diarrhea, and hair loss. Cancer side effects often depend on the type of cancer, though they can include the bleeding, diarrhea, and hair loss. How do you get radiation sicknesses? That's basically being exposed to a bunch of radiation instantly. But cancer, on the other hand, is kind of the opposite. It's a little bit over a long period of time. So gradually. Who discovered radioactivity and how was it discovered? Henry Becquerel discovered it. He's the picture right here. And he did it by looking at a mineral called pitchblende and seeing that it emits strange rays. So it's called it radiation. There are three types of ways that radiation can occur: through alpha decay, beta decay, and gamma decay. Alpha decay is basically when an element throws out a helium atom, a helium nucleus, and turns into a smaller element. For example, you have an element called uranium. You probably have heard of it. We'll be talking about that more soon. Uranium emits the helium particle and turns into thorium, which is the daughter nucleus. Alpha particles can be stopped from entering the human body by a few sheets of paper. Then there's also beta decay. Beta decay occurs when there's a neutron in the nucleus that's turned into a proton suddenly, and also an electron is emitted. But for example, you have an element called cesium, and it turns into a barium atom because a neutron turns into the proton, and that means it turns into a bigger element. And there's also an electron in it. A beta particle can be stopped by a sheet of aluminum foil. Then there's gamma decay, the most dangerous. Gamma decay happens when you have an element in an excited state, and it emits something called a gamma ray and becomes stable suddenly. For example, you have cobalt in an excited state, and it emits the gamma ray and becomes stable. Gamma rays can be stopped by a wall of lead, so they're the hardest to stop. A famous scientist that worked with radioactivity is Marie Curie. Marie Curie was born in Poland. She won the Nobel Prize 2 times in her life, one in physics and one in chemistry. She discovered the elements polonium and radium. Polonium's named after her country, the home country of Poland, and radium's, I bet you know this one, is named after radioactivity. She married Pierre Curie, who was also a scientist, and helped her with her studies. He also won a Nobel Prize, but she died on July 4th, 1934. Nuclear power plants. Why did I include this? Because they're run by radioactive elements. This is a light water reactor. Basically, some water goes into the condenser, and then it goes to the control rods. That's the part with the radioactive elements. And then goes through the turbine. And to the generator and powers the homes, as you can see in the picture. Famous or well-known radioactive element is uranium. Uranium's symbol is U, and it's named after the planet of Uranus. Uranium's atomic number is 92, and a guy named Martin Heinrich Klaproth discovered it in 1789. It's actually the first radioactive element to be discovered. But much later, more than 100 years later, Anton H. Becquerel discovered that it was radioactive. So it wasn't known that it was radioactive in 1789, because radioactivity hadn't been discovered at that time. Some common isotopes of uranium are U-234, U-238, and U-235. U-234 is the rarest of the three. U-238 is the most common. It's actually legal to own that one in small amounts. And U-235 is used in nuclear weapons. It was used in the Hiroshima bomb, but it was replaced by plutonium in the second one. Depleted uranium is used in bullets as well. Then there's plutonium. Plutonium's symbol is Pu, and it's named after the dwarf planet of Pluto. Plutonium's atomic number is 94, and it was discovered pretty recent, or kind of recently, in 1941 by Joseph W. Kennedy, Glenn T. Seaborg, Edward M. McMillan, and Arthur C. Wohl. Glenn T. Seaborg actually has an element named after him for his studies in radioactivity and chemistry. It's Seaborgium, and its atomic number is 106, and it's radioactive as well. Plutonium is used in nuclear bombs, as I mentioned earlier, and it replaced uranium in the business, and it was used in the Nagasaki bomb, the Fat Man bomb. And plutonium's 5 main isotopes are 238, 239, 240, 241, and 242. Also, I forgot to mention, plutonium, most people think that plutonium is synthetic. Technically, it is not. It is found in small amounts on the Earth, very trace amounts. Then there's thorium. It's the most common radioactive element. Its symbol is Th, and it's named after the Norse god of thunder, Thor. Thorium's atomic number is 90. Thorium was discovered by Jöns Jacob Berzelius. It was also the second radioactive element to be discovered. And thorium, one of its main uses is in coating tungsten filaments. Thorium's isotopes main isotopes are 230 and 232. Then there are medical uses of radioactivity. Although radioactivity can cause many problems, it can also treat them, surprisingly. Radioactivity, this is very surprising, can treat some types of cancer. It can also be used in x-rays, which see an image of the human body. Here's a picture of an x-ray of the human body. And thank you for listening to my presentation. And if you have any questions, please contact me.